there's anybody with any ideas or presentations or wants to kind of take the stage to talk, please let me know. That would be great as well. I've got to keep it short and sweet. Welcome yourself as well. I need to do something about the gender diversity within blockchain. It's a problem in Scotland. It's always been the same, but we can have a think about that one as well. But no, I'm welcome.
Super.
Really looking forward tonight. We've got two free presentations. Just going to get it. There's not going to be any breaks or anything. We just want to we'll go through the free presentations, then some time for maybe networking and after it as well. So welcome. Looking forward to it.
Thank you, guys. Right. So that's the presentation about. So what's that? Right. It's going to be quite a boring talk. It's about blockchain and yet another blockchain conversation. And this time a bit different. You know how the big guys are adopting this thing. It's called blockchain. Right. So why I'm qualified or here to speak about it? So yeah. So I happened to start quite early. So I was in the IT industry. I managed to find a job when I was 17 years old, programmer. So managed to start with Pascal. How many of you studied with Pascal? Yeah. And yeah, so I grew up as a distributor and cloud engineer, some entrepreneurial background, then you know, tech lead, tech advised some startups, and then you know, now I'm running Ocean. I have like one slide on Slash to explain what's that. And you might have seen those brands before. I have helped them to under digital transformation on their mission. Right. So blockchain on enterprise, which sounds a bit oxymoron because I think blockchain started as a totally anarchistic thing about decentralization and, you know, go against those big guys. So how come, you know, it's related to the big guys again? So who has heard the word blockchain that is being used in anything other than cryptocurrencies? Good. Okay. That's a good portion. Right. So I told you it's a boring talk. Okay. So I'm going to explain to you again about, you know, what's blockchain, right? So yeah. So what's blockchain, right? So do you see this little guy over here? So this guy, you know, is wants to, you know, publish a transaction somewhere. It has done an action and wants to notify the world that you know, something like that has happened. Now this guy happens to be a human. It can be a robot. It can be, you know, whatever you want to be. Now, in order for this to be known into a network, because blockchain is a blood network, it has to publish it to a computer. Voila. And this computer has to generate a magic thing, which we all know. Bear with me, I know it's boring. Well, this magic hash of this action, you know, it's gonna propagate to other little machines, and those machines is gonna reach a consensus. So this protocol, this is the protocol that, you know, blockchain speaks. And when they reach consensus, in theory, every other machine should be having a very identical or, you know, a copy of the data that they are interested for. And why I'm saying that? Bear with me. Right. So after all this, and you know, you pitch it to your manager, you pitch it to your client, you pitch it to your boss, and you know, the main response that you are getting is, you know, this is quite complicated. Can we just do it with APIs? So who has heard this similar response before? Right, yeah. Cool. So you know, being a business owner, I'm hearing this a lot. You know, why the fuck I need to use, you know, blockchain? That's fucking, you know, too complicated. Can I just use, you know, APIs? You know. Cool. Okay, so you go to the same person and you say, okay, dude, okay, let's use APIs, you know. Cool. So what do you want to do? Okay, what do you want to do with APIs? Who is not very old school, but who has done like an SAP integration before? There you go. Super. Okay. Does anyone? Do you guys know what SAP is? SAP or Salesforce, or you know? Anyway, they are the data gold of big organizations. Like they fall under the term of data management systems. So you know, whatever is on those systems, that's the gold truth for them. And usually it's an SAP system behind, and above SAP you will be hearing lots of different abbreviations depending on what SAP service they are using, depending on the industry, and you know, it might be above that like a Salesforce, a Hybris, or any other even more complicated system. So so the architecture, who understands architecture? Who understands this thing? All right, so what this is, right? So this is how organizations currently work. Okay, they use those SAPs, and they're having layers and layers of abstraction and other services in order to to distribute it to their application, and in order to make something trustable enough for the management to work with. So what does this service? Yeah. So let's have actually a very simple use case, so you can understand it, right? So SAPs and and Salesforce. So let's say that that you are having a logistics company. Some commodities are coming over to your warehouse, and you need to store them, and you need to go back to your e-commerce application and say, oh, now you know what, these blue jeans that you really liked are now on stock. So this synchronization to happen, it takes through this coping of data through these protocols that many of you haven't heard apparently. And what kind of technologies do you need to have in order to facilitate this coping between those organizations? So first things first, you need a copy in one machine and a copy on the other machine, right? So you need a local copy here and another very perspective copy here. That this would correspond to the web application. Then you need a distribution. Layer. Okay, this is what the Ale control does. It pretty much starts the information depending on the information. Then you need a transactional based message. So something that this system will understand. It will send it over an RPC API. Some mapping will happen, or some smart triggers will happen, and then through these triggers and mapping, another RPC call will happen. So when I say RPC for the new developers, imagine a JSON call or an AJAX call, okay, something like that. And then when this happens, you need to go through a very secure, and encrypted and channel that is going to use certificates and very other other secure layers on top of it, all the way to end up with a local copy on the other side of the room or in the world. Or you could just do that. So you could just very much end up with a blockchain system that the logistics pushes the data into one copy of the computer, and through the consensus, as I described on the boring part of the presentation, you will end up eventually synchronized on the other end of the world, and then through the other copy, your e-commerce application can immediately get notified. So what are the features? And all the features that you wanted to have before pretty much are out of the box, pretty much from any kind of major blockchain protocol that you'll be using out there. So data replication, check. Encryption and authorization, check. Every wallet is by far more secure than any other web application that you have built. Transactions, check, and everything else. So where's the complication, right? So why do we still see this as a complicated route to success of the technology? I mean, this is much simpler than this, and trust me, like each component of this has even more complicated things that I don't even know. So let's pick market size, right? So in order for this to become a reality, 23 billion have to be spent by 2023 as a blockchain software spend in order to make it a success. Now, if that's the case, many have made a report that going through the model, there's a lot of benefits into the market in those three major ones, and there are other major characteristics that will happen on other businesses as well. But in order to go this, there are three main challenges. From our research, we have split them into three main categories: governance, governance and operation, regulation, and technological ones. Who knows what those are? Super. Okay. So if you don't know what they are, without those organizations, you wouldn't be having names on your domains, and you wouldn't be able to have an IP on your service. So we already have a very distributed system that is currently working, and one example is the name service, and the other example is the IP allocation. So why those why there's no chaos, right? Why are we still working? Why those two are less complicated than this? So the main explanation is because first of all, they are American based, and secondly is because they're very much regulated, and started being regulated, and they are non-profit. So then let's go to the first government challenge. So a blockchain is a network, right? So different organizations need to join into this network, and they need to play along the same rules. Now, for the current system to work, to make sense of an automated network to be able to operate, this doesn't make sense to anyone. Currently, what is this? Who administrates that? Who decides its architecture? Who do we have to create like another non-profit organization and call it Ethereum, or call it Ethereum Alliance, or call it something else? Do we trust it already? This hasn't been solved yet. Also, blockchains are networks that are irreversible. So currently, what happens when there is a trading embargo? Like if blockchain ever gets the hype that the internet has or the web technologies have, how are you able to how is the US able to force an embargo to China? To stop the private sector trading from China. Does it have this authority anymore? and if it doesn't, it will feel very much insecure about this. Should it be a democracy? Actually, should joining a network be a democracy? So all these are the government's challenges of adopting the blockchain technology on the enterprises, and this is on the government's sector. But who doesn't know them? But who knows them? Super. Okay. Cool. So what? Okay. So what's their role, right? Their role currently on pretty much what why we need them, right? We need them in order to make sure that someone would be able to blame if something goes terribly wrong at the current structure of our trade. Either this is through exchanges or through private deals. We need by the way, these are the top 4 auditors that are globally acceptable. So big companies are just outsourcing the risk of taking a big decision to them, and they take the risk to execute this decision by signing by being responsible to sign off big deals. Right. So how do we do that on blockchain? Does anyone know? Or right? Okay. So no one knows, and that's the global truth actually. And actually, I was just yesterday in an event hearing the the Calibra guys just speaking about the first, even the first part, how you can give access enough to auditors to say that you have the full picture to audit me, but I don't want for you to have the to reveal the full picture to the network. I don't want if I'm Shell, I don't want to give the full access to BP to see with who I trade with, what my trading channels and stuff. But I understand that the auditor needs to have them, so I need to be able to give a very scoped view. So this is currently not solved by any blockchain. Currently, there are many discussions about zero knowledge proofs and side channels and side chains and other fancy technologies, but none of them have proven any significant value. I think the most promising one as a POC must be the EY's Nightfall project. You can check it out; it's on GitHub. Do we want? Actually, as a regulator, if something goes terribly wrong, do we want actually the immutability? Actually, do we use blockchain because it's immutable, or do we use blockchain because we are able to syndicate data between people that we don't trust with? So is immutability actually good? Enterprises corporates haven't decided yet. This is why Accenture has patented a immutable blockchain, actually, just to fill this kind of personas and requests. What about future laws that we haven't that we don't know yet? So if blockchain was a thing 10 years ago, 5 years ago, EU came up with a law to the right to be forgotten. So you have a complete right to ask someone to delete your data and not be publicly available for something that actually harms your profile. So what if a new kind of law comes in 10 or 20 years? These are cases that the protocols that will get the mass adoption from the enterprise need to be scalable enough to adopt. Otherwise, no one is going to sign off a production ready case to actually write data that it would be responsible for someone. And which protocol actually? Should we have a common protocol? Should we have an R3 Hyperledger or something new? We still actually don't know that. Yep. So yeah, going to the technological and most fancy. By the way, actually, how many of you were expecting a tech showcase today? Cool. Okay, so no one. Good. So who is brave enough to tell me what the Google Drive and any kind of blockchain have become one? Go for it.
Shared write and read access?
Yeah, you are quite close. Yeah. So okay, so sorry. The store data, yes, about your organization, right? Yeah. Right. So the data that you stored on the Google Cloud, right? So say that you're working, you work for a company, so and you just upload it on the Google Cloud, an NDA that corresponds to your company, right? Did you pass through the firewall of your company to upload this NDA? You didn't, right? You uploaded straight to Google. So if you alter this document that is information of your organization, would you pass through the firewall of your company? So would your company be aware that an information that corresponds about them has been updated? So they won't, right? So they have like no control over the information that applies to them. So similarly to blockchains, the information that someone will alter on your smart contract or on your chain con or whatever, pretty much, won't happen through your .com firewall. It will happen locally on the computer of the user, and then this user will publish the update through the consensus algorithm that I showed you earlier, and then eventually you will know that someone has updated your records. So architecture, right? So what we have been doing like so far as architects is that in order to prevent those kind of scenarios, actually corporates have been banning Google Cloud just for this reason. And other Dropbox-like cases, because it's very convenient for them. Actually, I have the mouse. It's very easy for them to create demilitarized zones into the web. Who knows what a DMZ is? Okay, cool. Yeah, cool. Okay. So what's a DMZ? So if you can consider like your critical services into tiers. You have the most vulnerable to be accessed by someone else into a DMZ zone, so a bit more flexed firewall, you could say. And as you go deeper and deeper and deeper, you'd have your golden data into a network that doesn't even touch this internet at all. And why you do that? Pretty much, you don't want people that access your API to be able to have a same-level access that your bank invoices are, for example. So larger organizations, this is the blueprint of how they're mostly accessed, and this has been super convenient so far, because if you wanted to do anything with my data, is that you will have to go through my delimited zone, even if you're an IoT or a web app, a mobile app, you'll have to go through my API, and then this API I would having my authentication gateway, and then this authentication gateway would route your message through my service bus, and then the service bus would do something about it. Now with the blockchains, on the blockchain world, this doesn't happen for the same reason that I just explained. So blockchain doesn't care about your API, doesn't care about your .com thing. Actually, you can actually not even have an external access to your blockchain. You can just whitelist all the nodes that you want to go directly speak with, and still get the whole traffic of the world that you want to be connected with. So this is a huge challenge. This is a huge challenge because now my firewalls that I have been spending millions and millions to build, they don't apply anymore. So this means that if a stupid developer of mine pushes something and leaks the data, or someone is or a troll find my data and somehow manages this in the way that I didn't thought about it, they are there and I cannot block it. Okay, so this means that that building so blockchains need a whole new architecture to build a whole new demilitarized zone to firewall them and make them secure enough for your organization. Right. So fear not, though. Even from all those challenges, there are many active cases out there that you guys should have an eye on. So, how many of you know what a blockchain consortium is? Cool. Okay, so a blockchain consortium is pretty much an intranet, I'd say, an open intranet of corporates that they build a blockchain network just to trade a very scoped specific for a very trade scoped case. So there are many of those. They already have a very good adoption already, even with all these uncertainties. They are actually one by one people are trying to break them down. And if you want to have like more info about them, so those are the biggest ones, but those are not the only ones. More and more are popping up. And yeah, so just a few words about what we do is that Ocean is a team of domain experts in the cloud and distributed computing, analytics, and stuff like that. We saw a great need of all these challenges, because each of us has been working on large enterprise environments, and we understood that if blockchain needs to have the adoption that big data analytics should be having, or if they need to be any closer to the enterprise world, we are building for them pretty much a Linux kind of like an operating system of how blockchains can be deployed and work on enterprise environment. So we call it like the Linux or the open stack of blockchains. And so far we have been having like some good support with from big companies. And you can read about us on the internet. Questions? Oh yeah. By the way, we are hiring. So if you guys are looking, if you're an engineer and you're looking, we're hiring.
Any questions?
Do you help organizations find use cases for blockchain, or do you help organizations find blockchain as a solution for problems they already have?
We are not a service, although we partner with service providers that do this kind of service. We do provide advice, but our main scope is that when they have taken the decision to use blockchain and would like to scale, we jump, we help them to scale or do it on production, or in an environment that eventually can easily become production.
Corporate world, how are you finding the message going down that Hyperledger has with its public channel, its private channels, its private stores, its worldview and its private view, and the whole complexity of Hyperledger?
It's a good question. Yeah. So, right. So let me rephrase a bit your question, right? So, what is the the argument between private and public blockchains. Is this what we are?
The question is more about the understanding in the corporate world of such a hybrid environment.
Oh, they understand perfectly. They understand perfectly. Actually, the channels is the first thing that they understand, because they already have this notion of message bus. Okay, so if you just explain them that look, you are just building a message bus between organizations, they completely understand it. There's no problem around that. The problem that they don't understand is, what kind of data do I need actually to share between organizations to feel, that it will have a commercial return. But we are both the architects and the business owners behind that. Yeah, like once you tell them that a channel is pretty much a more secure way that you can you can have a message bus, but in a more decentralized way, pretty much. You can have a Kafka over the internet rather than behind your firewall. Yeah, they can quite understand. Actually, that's one of the catchy cases out there, that you can build trust channels between organizations, and instead of building APIs for every kind of new feature that you are building, you can have a private channel that you and your best buddy can speak with. Does this answer your question? Yeah.
Did you bootstrap this company and kind of grow it from zero, or did you get money at any point?
About Ocean?
Yeah.
If we got funded.
How did you grow from?
All right. Yeah. How did we grow? With blood and tears. And so we managed to find early demand. So no investment, no VCs is touching this thing, and we managed to find very hard support on this, especially on something that we're speaking about blockchain production. So imagine how niche this is. So no, we managed to find early commercial support from some companies. Actually, yeah, like if you read about our case with ClearScore and Roman Agora, like it's one of the cases that managed to keep us alive commercially. So now that we wanted pretty much to grow, now we are raising. We have just closed our pre-seed round, and we're going forward there. So yeah, we had to very much prove that this is the case, that if this technology goes bigger, it will need accelerators like Cloudera, for example, exist in big data, for example, or Red Hat exists in Linux. You always need the open source, but you'll need an enterprise distribution of the open source for the enterprises to trust it.
Excellent. And we'll be hanging around
Oh, sorry, yeah.
after for networking as
Yep.
well. Great. Thanks very much. Cheers.
Yeah, thank you.
Oh yeah. Yeah, if we start projecting. Great. Good evening, ladies and gentlemen. Thank you very much for coming this evening. I hope this is going to be an interesting talk for you. So my name is Michael Platt. I work for Microsoft. I've worked for Microsoft for 26 years now, and I was with IBM for about 20 years before that. So I was sort of a bit used to enterprise, I guess, after all this time. I've been working in blockchain for the last 3 years, and I've done a lot of proof of concepts, MVP type projects in that time, in most areas. So, areas like aircraft and supply chain and agribusiness, a lot of financial stuff, of course, lots and lots of different areas. And in the last year, 18 months, I suppose, we've really focused down into real production systems. So we've had probably about 300, 400 proof of concepts go through with different companies. But they're really mainly about training, mainly about people learning and so on and so forth. The question is, when are we actually going to get some real blockchain systems in production, and what are those systems going to look like? And that's what I've been working on for the last 18 months. And Evangelos' presentation was a very good lead-in, in fact, because his last slide is pretty much where I pick up, actually, because these are some of the companies he had on his slide. And what we see in the blockchain, or what we think of as the multi-party world, is there are people in a particular industry, be it insurance, be it shipping and logistics, be it trade finance, who want to work together. And indeed, they work together today, right? They actually do ship stuff backwards and forwards. Hey, you know, we get stuff across the oceans and all the rest as things turn up every day. So there's a process behind that, but blockchain can make that more efficient. And so what we found is that the two main areas are fintech and logistics supply chain for blockchain at the moment. And what's happened is the large companies have come together in those areas to produce consortiums or joint ventures. So this gives you an idea. So up on the top there, for instance, is a whole load of insurance companies. And they're actually working into areas such as InsureWave up on the top right-hand side, or B3I, which is also an insurance company, an insurance consortium. So what happens is you get a lot of these big companies, and they come together and they give some money to what effectively looks like a startup to go and build a blockchain system. So that's B3I. If you're talking about oil, for instance, there's a lot of oil companies in there. They'll come together to do oil trading, for instance, and that's done with a company called VACT. If you're talking about trade finance and trade in general, you can see people like the banks in there. They work with Comgo and TradeIX and Voltron, who are all on the previous slide. What I'm going to be talking about today is my personal experience with those consortiums, right? So all of these companies I've worked with all of these consortiums plus a number of others, which I can't discuss necessarily. But what I want to tell you is actually what this thing ends up looking like, what people are actually building today and getting into production. All of these companies in production. InsureWave went into production, gosh, I should know that. It should be burnt into me last January last year. VACT went into production last November. B3I went into production, can't remember now. Comgo went into production last October. So they're all actually in production, and we've learned an awful lot from those organizations. And in particular, I just want to put up some issues, right? So a blockchain system is a lot more than just the blockchain. It's a whole load of other stuff as well. And so you end up with actually a very complex and large enterprise-based system, right? But there are some differences between that and the case in the blockchain case. So when a normal company goes and builds a big application, be it a banking application or be it a shipping application or insurance application, they go and they deploy that thing into their organization and everything works well. If you're doing it through a joint venture and a consortium, it works very differently. Because first of all, the joint venture has to actually go and build the application themselves with the blockchain in it. And then they have to take it and they have to pass it out to all their members. Right? So in the previous slide, we saw VACT and we saw Comgo. They built the application, they built the blockchain system. They then have to pass that back out to people like Shell and Credit Suisse and all the other people that their products. So it's a much more complex business system than a standard application. So as it says in here, present deployment systems are basically for a single company, a BP or a NatWest Bank or Royal Bank of Scotland. They go and build an application. They have lots and lots of applications. They put those applications out there. They have to manage that, right? That's actually not the same as in the blockchain case. This is where we need multiple organizations have a single application which needs to be run by some central organization. So it's a sort of strange case. And the other thing that's happened is blockchain's obviously been of great interest, but at the same time there's a ton of work that's been going on in the whole DevOps, cloud native, Kubernetes orchestration space that's going on there. Hands up who are familiar with Kubernetes. Just a quick show of hands, right? You need to be familiar, right? It is where things are going. Everybody's going to Kubernetes, right? Which is a container orchestration, right? So basically the idea here is you take your application, you stick it into a container, which sounds just what it is, it's a container, and then you have a thing called a container orchestrator, which is Kubernetes, which takes your application and runs it for you. And if your application fails, it starts up another instance. If your If your application starts to run slowly, it starts up another instance, etc., etc., etc. So Kubernetes takes control of all the management for you. And that's pretty much where most large companies and small companies are going today, is using containers and orchestration. It's typically called cloud native, as the name for the whole area. It uses a thing called microservices architecture. Hands up, who's heard of microservices architecture? Again, that's the future. For all enterprise applications, they're all being built in microservices. So you build one of these cloud native applications, and then you roll it out and you manage it. In our case, in the blockchain case, we have to manage it across multiple organizations, and we don't have the tools today to do that. And so in a blockchain case, every deployment needs to be able to be configured both for the centralized member, for the network operator, what we think of as the network operator, the central joint venture people, and also it has to work in all these other different companies as well. And by the way, all these different companies all have wildly different infrastructures, wildly different InfoSec procedures, wildly different processes, and so on and so forth. So we've got to work out how to do it. So when people come to me and they say, hey, you know, first of all, we have the people, hey, blockchain's the future and it's going to take off and it's going to change everything. No. And then the next lot of people come along and say, oh, blockchain's dead, you know, nothing's happened, nobody's got any production, it's a completely waste of time. No. The fact of the matter is, blockchain is a very valuable tool, but it takes a lot of work to go and build it. A lot of work. I won't tell you how much those companies have spent in trying to build these building these systems, but it's a very large figure, because it's not an easy thing. Computer science is not easy in the enterprise. Fact of life. All right? It's just not easy, and it takes a lot of time and a lot of money, and we're working through that. And as I say, we are working through it because we're getting into production. However, as I say, a couple of things that are very important in the blockchain world. First of all, velocity. How fast can you get the damn thing out there, right? Everybody's focused on how fast you can get your applications out. In the blockchain case, not only do you have to deploy it across your organization, you have to deploy it across up to 300 other organizations. One of those consortium, I won't say which one, has actually got 300 members. Right? So you've got to get it across 300 different companies simultaneously. Secondly, as I said, not everybody is the same. I work for Microsoft. I would love it if everybody was on Azure. This is my sales pitch, right? Azure is the best. Please do everything on Azure, right? Anyway, moving on. The fact of the matter is that actually people put their applications onto other platforms. It's the truth. You know, there are a lot of other platforms out there, and people use them, and indeed on-prem platforms as well. It doesn't have to be in the cloud. We have a lot of people on-prem as well. So we need to be able to support all those different platforms that are out there. And then finally, as I say, something that Evandos also talked about is governance is very important. You know, this is most of these are very regulated industries, right? And none of them trust one another inherently. So they need things in place to prove that they've met the regulations and that they can be audited and so on and so forth. And in fact, I've worked with a number of auditing companies who are doing auditing on the blockchain because they believe it's actually, they can do a real-time audit using the blockchain, and that gives them a big competitive advantage. Right, so these are the sort of constraints, these are the additional constraints that we have on building our application and our systems that normal systems don't have. So what does this thing end up looking like in terms of an architecture? What do people actually end up with? So this is pretty much what every company, every consortium out there today in blockchain looks like. This is actually, of all the consortiums I'm working with, I think they all look much like this. And by the way, nobody's actually got to this full level. And also you can see I'm not a designer in any way, shape or form, right? So I'm afraid this is just black and white. So what you actually have is, first of all, you have an industry, trade finance, insurance, and they have their space, okay, up at the top here. And they will have, you know, things like management, deployment, communications for that space. And this will be what the joint venture or the consortium is working. Then there will be the consortium, VACT, Comgo, Voltron. They all look the same, right? They will have a master node in the middle, which actually does all the communications. It does the master data management. It does the deployment. It does the infrastructure setup, et cetera, et cetera, et cetera. And it does operational management as well, okay? Then what happens is you have a set of nodes. And each node is where the blockchain is. It's an application plus the blockchain, and this is the piece that does the work. So your company, BP or Royal Bank of Scotland, comes in, they have their own node, and they work on that node and actually go and do whatever it is. Most of it's some sort of post-trade settlement, actually. Almost all of them are post-trade settlement in one way form or another. But they all have, you know, their application. It sits on a blockchain, and that's a node. And I'll come on to what's in a node in a little bit later. Now, today, pretty much everybody is running their nodes. They have a node per organization, and they run it in their own service, their own space, their own subscription, right? Very few people. There is only one company I know that is actually not doing this. There is one organization which has managed to take the node and give it out to one of the members. So clearly, what everybody would like to be is if you're a bank or something, you would like to have your own blockchain node, yeah, and running everything in that. And we will get there, but there are some issues with doing that. So today, what happens is they run them in this consortium space. As I say, there's one company that's actually running both here, and they have their own node outside. Eventually, everybody would like to have their own node, whether it's on Azure or AWS, hybrid, wherever. They would like their own node. They would like to run the application given to them by the consortium on their own hardware or their own cloud or their own subscription, and then integrate with this system in the center here. You also have, so that's the general case. You also have some specific instances where there are small organizations where they want to be able to work with information on the blockchain, but they don't want to run their own node. It's too expensive or it's too difficult or whatever. So to give you an example, I've done a lot of work with royalties. So Microsoft, you'd be surprised how much money we get from royalties for things like Xbox. We actually then get, we take the Xbox information, we pull that in, and then we go out to all the different games manufacturers, you know, Sony and PlayStation. Actually, funnily enough, Sony's one of our big ones as well. But people like Microsoft themselves, and then also people like Ubisoft, and I'm not a gamer, so all the games companies in there. We then have to pass royalties back to those companies, and they then pass them back to the games developers themselves on this long chain. You need to prove that the right amount's being paid all the way through, so you can do that on the blockchain. What you find is that there's a long tail. You know, in gaming, there's like 10,000 small mom-and-pop companies which are actually providing games, small games. And that long tail also needs to be supported, and typically that's done in here. And the same thing's true, actually, of oil. I was really surprised, because I thought it's all just the majors. But actually, each ship that goes down that goes down the canals in the Elbe in Germany actually is its own organization, right? And they actually need access to the blockchain for doing oil trading. So there are a lot that have this small requirement as well. So that gives you how the overall system works. When we look inside one of these particular nodes, what you actually see is this. It's not just a blockchain. I wish it was. It would make life so easy if it was just a blockchain. There is a blockchain, right? And to be honest, it doesn't really matter which blockchain it is. I've worked with R3, I've worked with Hyperledger, I've worked with Quorum, I've worked with Ethereum. They all have their pros and cons. R3, somebody asked earlier on about Hyperledger channels and the complexity. If you think Hyperledger channels are complex, try R3. It's even more complex. But obviously, as you get onto things like the more complex it is, the more flexible it is, and the more it can do for you. That's the usual thing, you know, standard sort of trade-off that you make. So what you have is you have your application up on the top there as a microservice running in its own container. I have one organization, they have 17 containers. Their applications in 17 different containers, yeah? Each container does a particular piece of functionality. That then sits on this central layer, which provides blockchain, obviously, a database. Pretty much everybody needs some data that's off the blockchain. Do you put all the data on the blockchain? No, you do not. Right? Please do not put all your data on the blockchain. It's a very bad idea. The blockchain is not there as a data storage device. Right? It will go very slowly if you do that. Okay. Messaging. In many cases, you want to be able to do messaging. Banks, as I said earlier on, Evangelos was saying, banks love messaging. They grew up with messaging. It seems surprising, but that's how they work today. They really understand messages. So they want to do things with messaging as well. Now, they obviously can use the blockchain for messaging, but almost always they want their own messaging system as well. They need to be able to do key management. You need to be able to keep the tokens. You need to be able to keep the certificates. You need to keep the SSH keys. All those good things need to be kept and held in some secure manner. So you need a key vault, a key management system. You need some sort of monitoring. We talked a little bit about APIs. You need an API system. So you can see there's a whole load of infrastructure that you need. And typically what you do is you take all of this stuff, put it all in a container. In Kubernetes world, this is actually deployed by using a thing called Helm. Hands up who's heard of Helm. Okay, so it's all done through Helm. You have a Helm chart for all those back-end things. So today, for instance, there is a Helm chart for Hyperledger Fabric. Okay, there is a Helm chart for Ethereum. There isn't actually one for Quorum or for Corda. Corda's building Helm charts for complex systems is quite difficult, and I keep pushing Corda to provide an R3 containered system. And if you look on the web, you'll see lots of people say, "Why don't you do a contained R3?" So those are actually deployed to these things called Helm charts. Istio is a thing called Smart Mesh. Hands up who's heard of Smart Mesh. Right. Smart Mesh, again, the future for networking. Yeah, it's where people are going in terms of networking. It's all done through a thing called Istio, right? And Kubernetes is providing the orchestration layer. And then finally, down at the bottom here, you have your base infrastructure that you actually have to run. Typically, that's done with a thing called Terraform. Hands up who's heard of Terraform. Okay, and Ansible, which is a provisioning agent. Okay, so then, of course, you need your authentication authorization systems, your security systems, and you need your CI/CD. And that gets us into the whole world of DevOps and how do you deploy these things. So this is your architecture. You've now got to deploy this across multiple organizations. It's not simple. There's lots of bits in there, right? So how do you do that? We're still working on that. I wish we had all the answers. But again, actually, this is quite remarkable because I promise we didn't collude on our slides. But we're pretty close at this point because the areas, as Amandos said, deployment, big area, governance and security, big area, right? I also have operations day too, which I don't think you had. But and by the way, this is the technical side of things. I'm not talking about the business side of things at all, right? Because setting up JVs is and governance of joint ventures is a whole new ballgame, right? So if we talk about the deployment side of things, again, these are the words you'll hear: cloud native, microservices, DevOps, CI/CD, GitOps. These are the technologies of the future, right? And that's what's used to do the deployment. So you need to be able to do your infrastructure using infrastructure as code. This is like buzzword bingo here for deployment, I can tell you. So there's networking. So this gets into areas like ingress management, service meshes, right? Again, important technologies. The next one is how do you manage and containerize the applications themselves, right? Including the blockchain. That gets into the Helm and Helm chart side of things. Application infrastructure storage, so that's the whole area of registries, container registries, those sort of things are all in that space, and deployment, which is all in Helm charts. So Helm's Helm's the actual service that runs. Helm charts are what you run on it. So you actually have it's actually a set of YAML that you run on your system to set up the Helm. And then, as I say, CIDs, DevOps, and GitOps. These are all important areas. They're used for the pipeline. So the central organization building the application has a development pipeline. It has a CI, continuous integration, continuous development, or continuous deployment pipeline that runs through it. And that's actually how people like Netflix and Amazon and Uber and all those companies do things today. Now, big companies would like to do the same thing, but they really struggle because they actually have to meet a whole load of security and governance requirements. And so therefore, it's very difficult for them to do continuous deployment. Continuous deployment means I'm going to knock out, I think Amazon does like 100, 200 deployments a day. And you have things like canary deployments and red and black-green deployments as different mechanisms for you doing your deployments. Unfortunately, those sort of don't work in the enterprise space, and that's a big area. If anybody wants to make a few $100 million, then do a startup in that space, because I tell you what, nobody's got any answers yet on that, how we do that. And it's not just blockchain, it's just in general for enterprise. Second thing I want to talk quickly about is operations, what's called day 2, or shift left is the latest thing that you'll hear. Shift left means you're taking stuff from later on in the cycle and moving it back up. That's all it means, right? But it's basically around day 2 ops. And so when you're talking about operations, some of the things again, master data, you have to take the master data, you have to pass it out, you have to synchronize it, make sure everybody has the same data. You have to have the messaging I was talking about earlier in there. Messaging is a real problem because if you want to send messaging from one cloud system to another cloud system or to on-prem or something, then you have to have the same messaging system at both ends. And that's actually quite difficult because whilst everybody in theory is an AMQP-based system, in practice, none of the AMQPs work together. So, you know, you actually then end up saying, well, I have to go to something like RabbitMQ to provide messaging, yeah? Monitoring, right? So monitoring is a very new area, especially in the Kubernetes land. You can monitor Kubernetes. It's very difficult to monitor what's going on inside Kubernetes. There's a thing called Kubernetes operators, which actually provide you, and CRDs, custom resource definitions, which actually allow you to get to into your containers and pull information back for your operations, right? So that allows you to do things like billing. It allows you to do things like backup and restore and so on and so forth using operators. You also need to have, so if you're the joint venture, you don't just have one Kubernetes instance now, you have your own, but you have all these other instances in other companies. You have to manage them. You have to start and stop them. You have to reset them. If one of them goes down in the blockchain world, it's almost certainly going to stop everybody else working, right? It's just the way things are, I'm afraid, until we've got a way to go yet before we can make sure that the whole blockchain is completely fault tolerant, right? Or, sorry, all the applications built on top of the blockchain are all fault tolerant. So you need to have some way that the joint venture, the consortium, can actually control things and turn them off and on. and you need to be able to go and see what's happening in your system. One of the problems with Kubernetes is far too much at 34 billion for basically for OpenShift, because the rest of the Red Hat stuff is pretty old. 34 billion, it's like ludicrous, but they completely bet their company on that. Finally, governance and security, you'll hear that, it's called DevSecOps or policy as code. There's a thing called OPA, which provides, stands for Open Policy, can't remember, which basically provides the policy. Obviously, you've got things like authentication and authorization. You have to do that across multiple different auth systems. Again, you have 5 different companies, they will all have different auth systems, right? Be it IMS from AWS, be it AAD from Microsoft, be it, I don't know what Google uses, any auth 2 type systems. You have to have some way of working with all those different authentication systems, right? You need to be able to do RBAC, very important. You don't want anybody going into your blockchain system and changing it just because they've got a Kubernetes access. You need to be able to lock it down. That RBAC has to run, by the way, not just in your organization, it has to run across all the organizations. Yeah, because you don't want somebody in Shell coming in and having a look at what BP's doing either. Right? Token management, we talked a little bit earlier, key token and certification management. Give you an idea, sort of problems there. One of the consortiums had 3 different companies with 3 different certification authorities, and none of them would allow the other certification authority to work. It took 3 months, and we had to go to the head of the company to get sign-off so that they could use a single certification authority. It takes a long time to sort these things out. InfoSec, DevSecOps, I talked a little bit about already. Again, huge area, still wide open at the moment. And then we're getting into the whole area of regulatory audit and compliance. The regulators know about this stuff, and all of these organizations, they have to provide regulatory information. They have to do it with things like SOX. They have to do it with things like the ISO, it's 9001, I can't remember the number offhand. And PCI, which is probably the hardest, which is to do with credit cards. And they have to provide all that information, and they have to be authenticated, they have to be authorized, they have to be certified to do that. So that gives you an idea of why it's taking so long. So when somebody comes to you and says, this blockchain thing, nothing's happening, why is it nobody can actually get a blockchain out there? It's because it's hard. Not impossible, but it's hard. And just firing up the blockchain is just a first step in a long process that has to go through. Now, are people going through it? Absolutely. Every single major Fortune 500 company, or Fortune 100 probably, company out there has some sort of blockchain system running. okay, or is working on some sort of blockchain system because they believe it. But it's not going to happen overnight. Okay, any questions? Go ahead.
So you work for Microsoft, and so why don't you use Service Fabric instead of Kubernetes?
We can use Service Fabric. At the moment, you could do all this in Service Fabric. One of the problems with Service Fabric is it only runs on. You can run Service Fabric on-prem, and in theory, you can run it on AWS. Actually, I've never tried to get it running on AWS, and I have no intention of trying to do so either. The standard company line is you could do all this on Service Fabric just as you can on Kubernetes. My personal opinion is Kubernetes is long gone. Right? The future is Kubernetes. What?
Is it just won the battle then?
You know, how many people here have heard of Kubernetes? Yeah, how many people have heard of Service Fabric, right? Exactly. So I know it was a trick question, right? I've been with Microsoft a long time, right? And something I've learned is that sometimes we have good technologies and sometimes we don't, right? Sometimes we win, and sometimes we have bad technologies and we still win, which is completely mind-blowing to me, but is the truth. So actually judging which is going to be the winner, I find extremely difficult thing to do. But when it's transparently obvious who's the winner, then I'll go that way. Yeah, I'm being videoed too, so I hope my boss doesn't see it. Any other questions? Okay.
Yeah, you mentioned that there's difficulties of going through this process from deploying a block from I have an idea to actually putting it out there. What do you think takes up most of people's times in deploying these new technologies?
It's just at the moment we've sort of got. We're sort of at the centre of a perfect storm at the moment. There's three things going on. There's the whole area of trust, people working together, multi-party, which is transpires into blockchain. So people have this concept that they fixed everything in their organisation. It is absolutely not true, but that's their feeling. Is that all their systems are brilliant and they're wonderful, and they believe their next future cost savings and improvements are going to be from working with the other companies. And in order to do that, you need a trustable system, and that's why blockchain is so interesting to enterprises, right? Not necessarily true, but I'll go with it. The second side of things is that, the whole cloud thing, right? You shouldn't have stuff on-prem, you should put it all in the cloud because we'll manage it for you, and, it'll make it easier. And so, again, sometimes that's true, sometimes it isn't, right? So you need to be careful with all these things. But so there's a cloud thing, there's the cloud thing, there's the trust thing around blockchain, and then the third thing that's coming through is this whole what they call cloud native, which is basically a new way of writing applications. The whole microservices, the whole containerized applications is really a new way that people are architecting and building applications. And the trouble is all those three things are coming together more or less simultaneously, which is great for people like me because, at the moment, the best paid people are DevOps people, right? Because you need DevOps people to put all this stuff together, and there are just not very many DevOps people who know this stuff. So, hey presto, my salary goes up very nicely, thank you very much. But what happens from a company point of view, it's very hard to find people with the skills in order to build these systems, and therefore, the whole thing goes very, very slowly, which is what we're seeing today. And we'll see it, just like we saw in machine learning 2 years ago, 3 years ago. Hey, you know what? Machine learning is the answer for everything. And by the way, you need data scientists everywhere. And so probably everybody now in this university is learning about data science. Next year it'll be about you should be doing DevOps. And by the way, by the time you graduate, it'll all be too late anyway.
Data engineering markets.
So I shouldn't have said that last one. Sorry. My personal opinion. So this industry moves very, very fast. And so today the hottest topic is DevOps. The hottest people are DevOps. And that's what's really blocking the whole thing. Is just we don't have enough skilled people. So it's a great business to be in because I tell you I've been in it 40 years and There's always a new job around the corner, I can tell you. Always. And it's always better paid, too. Go ahead.
You know, you're talking about the model about moving some of the heavy lifting of the data repository off to the database and not on the blockchain.
Yeah.
You know, in your experience in working with the consortiums and whatnot, is that like a central database the members trust together?
No, definitely not. No, so what tends to happen is when you look at the transactions that go on, there's a lot of information that flows backwards and forwards, like name and address and so on and so forth, which isn't particularly confidential, which they still need to know. And then there's like, okay, this is how much I'm paying you, yeah? Which is typically what, if you look at an invoice, there's like name, address, date, etc., right down at the bottom it's like how much I'm going to pay. The bit that's important to everybody is how much certainly with me anyway, is how much I've got to pay. That goes on the blockchain. All the rest of it goes into the database, right? That's pretty much how it works. So absolutely, when blockchain first came out, everybody said, hey, you know what, we'll just put the whole invoice out there. All the information, yeah, we'll have all these names and addresses. And it's like, whoa, that slows it down. So they took it all out, and it's called off-chain now, and it's a well-known technique. And so you literally just keep the transactional information, the minimum amount of information. Okay.
Just to get a sense of scale, how many people are in your team, and does it require such a big team that only large organizations like Fortune 100s can do this kind of stuff, even though other ones might benefit from it, or?
That's a good question, really. It's not about numbers of people, really. It's about skilled people. It's back to the usual thing that you can have 100 mediocre people or 2 good ones, right? And they'll actually do this more work. So we don't. On my team, there's only a couple of. I look after Europe, and somebody else looks after US. But of course, there are a bunch of other people inside. Microsoft's a big company, so there's a lot of other people, both in the field itself who look after customers, and then back in the product groups who work on the products. And I'm not talking about any of our products, which I probably shouldn't have done, but that we have a bunch of products in the space as well. And so basically, there are a lot of people, and we tend to come together as a virtual team. But even then, we don't really have enough. And we're not the only people by any manner of means. I think other people working in this space struggle as well. And so typically what happens is the customer, there'll be a joint sort of development where the customer themselves, those consortiums, they will have a team of people as well, which is again typically a fairly small team. And we act as consultants to those people. And then they actually then hire typically 2 sets of people. They will hire a large GSI, global system integrator, who will go and do the actual major part of the development work. So all those blocks at the top, which said application, it's all React and Node.js. They'll go and get rafts of React programmers from India to go and write that stuff, right? The Node.js typically is done in Eastern Europe, as it happens. And then basically the infrastructure side of things and the blockchain side of things is normally done by specialists. R3, on most of those things which are running R3 Cordova themselves will actually come and do the work and help. Similarly with the Ethereum-based systems, Consensus do a lot of that work. So what you find is there's a whole raft of different people involved in this to actually get it all to work. Right? So we provide cloud knowledge, a lot of this side of things. Accenture, Avanade, EY, etc., etc., etc. They provide basically the application development, the base application development, and the operational side of things. And then there'll be specialist vendors that are brought in for the blockchain side of things. Actually, interesting enough, nowadays you tend to bring in specialist vendors for doing the DevOps side of things as well, because until the larger companies catch up with how DevOps is done, then it tends to be done by specialist organizations. And those guys move like fury, right? Because every 6 months they're offered a huge sum of money to go. I'm not going to. All right.
Thanks very much.
Okay, thank you.
do a switch or do I end that presentation? Hey guys, how you doing? I think I don't have a huge talk to do, so I'll just start. My name's Stuart Pavitt. I'm the Chief Product Officer of Wallet Services. Oh, good, Michael's left. I can kind of say it. I think I will be the dissenting voice tonight if we get into certain things. I think with blockchain, specifically a lot of the big stuff, is it's really, really complicated. And what Michael was saying was absolutely right. As soon as you move down to ledger, I think there's options, and I think it's a really, really difficult thing if you've got 300 people in a node network and trying to combine stuff. A lot of what we've been trying to do is deal with these problems that Michael was talking about. So some of my talk will be a bit dissenting voice to what Michael was saying, but those guys are big and they're right, probably. Okay, so we started, so the first time I used the internet was 1995-ish. I was at school, loaded StarWars.com. It was awesome. It was like Macintosh, the Macintosh from Star Trek 4 Voyager, Voyage Home. It was really cool. It was black and white, loaded. Picture of Darth Vader, could print it out and picture it. It was awesome for a 15-year-old. It was everything I wanted from the internet. Then about, left school, went to uni about 2000, and I started filling in forms online. And that's pretty much where the internet has stayed for me for the best part of 20 years. We are continually filling out the same form, right? To the point where now Google, whenever I go to a web page and I've logged in with Google, it says, I'll just fill this out for you. So it fills in my name, my first name, my address, my date of birth, all that stuff. We are continually doing this. We are continually filling in the same information and passing it out constantly. Like everyone in the world who has ever asked me my name has it. They have my date of birth or my postcode, my address, and I have no idea how this is protected. This is a fundamentally big problem for us. Why is it? Well, the internet is awesome. I'm not dissenting. I think the internet is fundamentally the greatest thing that's ever happened to me in my life. It has made my life so much better. But there's just so many issues with it. Yeah, like even if you listen to Tim Berners-Lee talk or you listen to any of the early guys, they're like, yeah, we never thought about those problems. We never thought about security. Why would we? We were just like guys wanting to put chemicals together in CERN or whatever CERN does, electrical stuff. But now, the internet is just loads and loads and loads of silos together, right? And if you are at the gigantic level of banks and insurance companies and mega companies, then actually, as Evan was saying, API sharing is awesome. API sharing is the world. Like, it might cost you $5 million to share data between two organizations, but it's $5 million out of a budget of $34 billion. We've heard these numbers. It's really not that big a deal to create API sharing. But if you're a smaller company, like what happens if actually API sharing or building combined IT systems, as Michael was talking about on the gigantic global scale, is just too much to do? Like, what do you do if you are a public sector body in Scotland, or you're just a farmer sitting and you just need to do certain stuff and you need access to the blockchain, and you don't, and if you can't afford access to the blockchain and you can't afford and you don't have 5 million sitting around to do API sharing, what do you do? How do you actually interact with these silos? Well, what you tend to do is you drop to paper. Like, this is 2019 and we still drop to paper. I bet everyone hasn't probably gone a week without filling in a form, or maybe a month. Like really young and millennial, there's a few of them about. Like, I fill in a form at least once a month, either from my kid's school, or work, or something, somewhere. Like today, somebody just like in the nursery handed me a form and said, can you fill this piece of paper in? So, ticked the box, scribbled something, and it did something. Something will happen because of this paper. These were promises that we were told we wouldn't keep having to do, and we keep having to do them. And we keep having to do this because fundamentally the internet is a bit broken, and API sharing is not an answer for everyone. It's an answer if you've got loads of money, and loads of companies have loads of money, but as soon as you're not in that, if you have a budget or citizens to be answered to, or governments, or actually you're just a medium-sized company, API sharing is off the table. You can't afford 6 months, hire the devs, build the APIs, connect, deal with your auth problems, deal with your security, hope the other guys are doing the same and share, because as soon as you set that up, you change. So what do? You use paper, you use Excel. So what Wallet Services did, or what we've been trying to do for we've been going 3 years, is we wanted to solve these problems, right? So I was employee number 7. The 2 founders, or the 3 founders at the time, but 2 now, came about and they went, digital life is really complicated. They didn't want to deal with paper. They were setting up a company and it was paper, paper, paper. They were doing something. Like, as soon as you get to my age, 40, and if you're over 40, you'll know this to be true, and if you're under 40, good luck. Your life just becomes lots of forms and lots of really horrible existence of just filling out stuff. Like, the promise that we were sold with the internet, it's not happened yet. Like, we get loads of cool stuff. We get, like, games, and we get, all that crap on our phones. Brilliant. Still stuck with filling out paper. So, we built Sicker, and we envisioned Sicker to solve this. So I started 2 years ago. LinkedIn just told me I'd been at my company for 2 years. That was really exciting. So 2 years ago, we kind of started on the journey. 10 months later, we demoed the first version of Sicker to this meetup in the other side of Edinburgh. And Sicker at that point was a workflow manager built on top of a blockchain node. And what it could do was it could allow actor groups to be assigned a series of steps, series of fields, and then the actors to pick which fields got sent to which actors. And it was quite basic, quite simple, but it worked. And then it proved the concept that actually, yes, you could build applications that were useful on top of blockchain, and you could deal with the really secure problems of data security, data transmission, encryption, all on top of blockchain, and all with applications. So if we fast forward now, before we fast forward, what was really interesting about the blockchain problems in 2 years is Michael was absolutely right. Blockchain has had so much trouble getting to where it is now and where it needs to be to survive as a technology. If you compare it to databases were invented about 1972. Blockchain was invented about 2008, 2007, so it's had 10 years. Databases had 10 years. Databases didn't have the internet, and databases were everywhere. Well, by like mid-80s, databases were pretty thing. You couldn't watch Superman 2 without seeing a database on it. It was in films, it was in media, everyone was using databases. They were, like, all the big companies had adopted the database. We're still trying to get there with blockchain. Why is that? Well, because blockchains really have 3 big problems, and I think a lot of what Michael was talking about was trying to address these 3 problems. The first one is, once you have a blockchain network, it's really difficult to get people on board. Like, if you've been running a blockchain network, 5 of us have been doing it, and then somebody wants to come on board, it's really difficult to come on, right? And then if the protocol changes, you all have to change, or you're out the network until you change. But if you're a critical member of that network, you have to get everyone on board. Right? And you have to compromise some of your identity, because blockchains work on wallets, and wallets are owned by individuals. Yeah? So I have a wallet, I have a Bitcoin wallet, doesn't have a lot in it, I was late to the party. I'm sure a lot of you guys have Bitcoin wallets and you have X amount, but it's yours, right? It's not shared. Organizations don't really like this concept. Organizations don't like this concept because pretty much humans are replaceable. Organizations, I have a job, I have a role. If I decide to do something else, they can get somebody in to replace me. They won't look like me, but they'll have my roles and access. And that's where blockchains and organizations have really sort of struggled to find a way together, because it's not Stuart's wallet, it's the CPO at Wallet Services wallet. And if Stuart changes, and he's replaced by Jim, or John or Michael, then they need all the same access, but I took the keys with me and I'm not giving you them back because I don't want it. So organizations have this problem. And then you also have, when you join a blockchain network, you're giving up some of that organizational structure. You're shaving stuff with a group of organizations you don't trust. And some organizations aren't legally allowed, and some have real ethical dilemmas about this. The police are not allowed, in Scotland and the UK, really not allowed to do certain things with the data. The data they hold is really sensitive. So they cannot do these things. They cannot access these benefits in this native way. So, where did we get to? So where have we got to as wallet services in the last 2 years? So 2 years ago, a year ago, we demoed to you a very simple workflow manager on top of blockchain. We had active groups, we had a series of steps, series of fields, and we could pass them about. Since then, we've sort of worked with a lot of customers. We've now got customers in several sectors. We work in the oil and gas sector, we work in the space sector, we work in the construction sector, we work in public sector. And what we found is these problems that all these organisations face are fundamentally the same. They don't want to do API sharing. It's either too expensive, or it's an ongoing maintenance, or there's too much organisational problems in the way. So what they really want is a way of easily and quickly coming together, creating processes that they all are working on anyway, like all organisations do cross-organisational sharing. You know, whether it's an employee, like an organisation using a contractor, or whether it's a series of insurance companies all working together collaboratively, they all have to work together. Organisations don't work in a silo. They all pass data out and they all get data, right? And what they really, really need is a simple system which allows them to set this up. So what we have here is the designer, and this started out, the first demo I did a year ago had 3 steps. You know, we still have a title, we had a series of active groups. 3 steps: put in data, validate data, authorise data, get result. Brilliant. It was good. Since then, we have now been working across all these sectors, and we've just extended it for the last year and a bit. We've just been constantly extending the features, constantly making it more configurable. And now where we have workflows like this on the other side, which are completely built on top of a ledger, right, which can be shared across organisations with really none of the real hassle that shared APIs do, you know, and none of the hassles that we identified with blockchain networks, because Sika has been designed to take these issues away. We built Sika so that Sika could exist within your organisation. So you didn't have shared protocols, because it's all uses REST APIs. So REST APIs don't really change a lot. This is all sort of encapsulated within our models, so there's no real change. You don't have to share administration, because the organisation, the actors that exist within your organisation, within your workflows, belong to you. Nobody else needs to see them. Nobody else gets to see what's in your data. Everything's, kept internally to your organisation. And your deployments, well, Sika has version management, so we can go backwards and forwards, whatever. So organisations are no longer tied together, because we built this layer in between the native ledger technology and this. So this process on the right-hand side was taken from a customer. I had to change it because of IP, but basically we have a very simple, a bit more complicated. We have a procurement process done by organisation A. Somebody will validate it, organisation B. Organisation C will submit design specifications. A will validate it, then we have manufacture. We have forking, we have splitting, we have workflow management. But instead of all going into a central database, this is going into a ledger, and then it's getting distributed between multiple organisations. Okay, and this is what we're doing, and we're working with, and our customers are using. Moving on, I thought I don't want to take a lot of time up, because it's 8 o'clock and we want to get done, and my mum might call me. Honestly, that's not a joke. It's really embarrassing. So please, if my mum calls, everyone pretend you're not here. But we thought we'd talk about a public sector customer, one of them. So this is this idea where we have a workflow process sitting on top of a chain, well, it's not a blockchain. A year ago, the first demo was a blockchain network. It was a Bitcoin native client that we used as the underlying storage. Since then, we found problems using native blockchain, which just caused issues and caused technical issues, and we decided that proprietary ledger technology would be better, so we wrote our own, and it's kind of worked for us, and it's given us all these advantages. So, for example, somebody comes in, they want an entitlement. A local authority, they may live in Midlothian, where I live, they may live in Edinburgh, where some of you guys live, you might live somewhere else. If you want entitlements in Scotland, you go to your local authority. There's 32 in Scotland, right? It's not a central body. There's no master organisation controlling everything. The 32 just exist on their own and share data, whatever crazy way they came up with. Some are using old APIs, some are using paper, some are using probably Messenger. But this person applies for a entitlement through their local authority. Now, that local authority will process as much as they can, and I'm not an expert in this, but somebody else will come in. So the local authority will validate this person exists. Yes, that person has a Midlothian postcode. They must live where I live. Yes, I recognise them. They're on the electoral roll. Cool, we validate them. Okay. The next person, Skills Development Scotland, which is a public body in Scotland, non-profit organisation. Yep, I don't know. They will endorse it. So what they will do is they will endorse this. Somebody will verify it and will authorize it. But instead of API shaving, where this person's would have just together and sent here and sent here and sent here and sent here, what we can now do with Sicker Workflows is this person, the local authority can create an attestation within the wallet, within the ledger. And then that attestation is passed across the network. So they say, look, hey, if you want to see this person, look, this person registered, we said they were the Midlothian resident, and here's the transaction that we say we did it, and we stand behind this transaction. So Midlothian Council will say, Stuart, he lives in Midlothian, he's paid council tax and whatever. But instead of passing all this information across through OIDC, which is what we've been doing for 5-6 years, they will pretty much just write a transaction to the ledger to say, we attest this, right? And then if another organisation knows Midlothian Council, they just have to say, right, we know Midlothian Council, we'll check the transaction source, it says https midlothiangov.uk, okay, that's good enough for us, this person's data is valid. So straight away, with our technology, we've stopped data sharing, we've stopped data APIs. And what we've allowed people to do is write things into the ledger and then reuse it. So that constantly filling out forms hopefully becomes a thing of the past. When you just go to a second authority and you're like, actually, here's my wallet, just find the attestations you want in there. Here's access to my wallet, just find them. Oh, cool, you're a Midlothian resident, tick. Oh, cool, you're over 40, tick. Oh, cool, you went to Napier, tick. Yeah, Napier. Oh, cool, you've got a job, tick. Okay, you've got kids, tick. You need child benefit. Okay, you know, whatever, blah, blah, blah. All this is now just ticks, and instead of this data constantly having it regurgitated to Midlothian Council, to Disclosure Scotland, to Skills Development Scotland, to Young Scot, to all these agencies, they can all just go, as long as they're on the network and they've got access and the person has control, they can just point them at the attestations and say, look at this. Yeah, that's got to be a better world. That cuts down so much traffic. That cuts down so much effort, so much processing. Public sectors, organisations can be more effective. They can use their money better. Yeah, they don't have to build expensive IT systems and pay developers. They just have to do this once. They just have to build these processes, publish them and share them. And as long as they're part of the network, everyone can use them. Okay? Then we get on to private sector companies. We have two. We've got agriculture. I saw somebody else was talking about agri-food. Yeah, we've got an organisation, and what they are desperately trying to do is prove chain of custody for GF oats. They want oats. People don't want gluten. Oats don't contain gluten, but if you mix them with wheat, then people are allergic to wheat. I'm not, but some people are. And people want to prove this. If you buy something and you're allergic to wheat, you want evidence and you want to be able to prove it, and you want assurance that you're going to eat it and not have an allergic reaction. All coming together, we can just do a complete supply chain. This is possible. We are doing this currently. This is in production. This is not, this is, well, it's coming to, I shouldn't say it's production. We're proving the point. And then another customer we have the oil and gas, we have the oil and gas sector. And what we're doing here is, the problem with oil and gas is everything is really, really, there we go, there's my mum calling me. Told you it would happen. I'll hang up on her, she'll never know. Oil and gas is really, 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 really complicated, right? It's like, as somebody, I was listening to a speech on YouTube the other day about oil and gas, and they said, sending a man in the moon to space is easy. You just have to keep all the atmosphere out. The problem with putting something to the bottom of the sea is you have to keep 2,500 atmospheres out. So everything has to be built right, yeah? Everything has to be built. You have to make sure the right guy that welded it has the right certificate. You have to make sure the person that gave him the certificate, had the right authority to give him the certificate, and you have to prove the certificate was right, and you have to prove the weld seal was right, and then you have to test it. So you have to sync it anyway, and you have to do loads of testing. And this just creates, if you're building something like something that will go to the bottom of the sea, you build it and it costs you 100 million to build because it's really complicated and it involves tons of organisations. But then you have to keep the chain of evidence from, hey guys, let's build one of them because I want to extract some oil, all the way to here's every single person. So these organisations end up with mountains of paper. Like it's like, you know, they will end up with a ton or 2 tons or 3 tons of paper, which is just photocopies and photocopies and photocopies of certificates. And unfortunately, when stuff goes wrong, like Deepwater Horizon, all that happens is you just bus in the lawyers and they start reading the paper and they keep trying. And all the Deepwater guys were trying to do is they're just going through it, trying to work out who did what wrong and who let them away with it so they can assign blame. But that costs a ton of money. Yeah? So, and you can't navigate paper easily, as we all know, right? That's why paper sucks, is we can't really use it. It's just there. You have to start at the top of a book and you have to go down. And you just have to keep reading until you find it. So what we're doing is we're using Sika to build complicated processes which will allow the operators, the tier 1s, which are the big guys like Chevron, the tier 2s, the slightly smaller guys but still gigantic, the tier 3s, now we're getting to small, medium-sized organisations, and tier 4, the mom and pop stores, who are just doing something, to all collaborate in a network to build this thing. But instead of having to deal with all this paper that is just chasing the wellhead, if that's what you're building, through the country, through Europe, or through Europe and a bit of America on ships, and just have it in a single ledger, which is immutable, traceable, trackable, and you know, navigatable. So yeah, that's what Wallet Services has been pretty much doing for 3 years, and we will we'll continue. I was going to do a demo, but I am really, really bad typing when people are watching me. Honestly, it's not worth it. It's not worth watching me a demo, but we're going to come back. Unfortunately, Peter wasn't meant to do tonight, but his wife's graduated, so he couldn't do it. And then Stuart was going to do it, and he's got babysitting issues. And then Hannah was going to do it, and she's in Bristol. And unfortunately, you got instead of the Barcelona team, you got Steph. So yeah, I've got if anyone's got questions, please ask away. Yeah.
My turn.
Yeah, crack on. Ask me one more question. Hey, are you using Service Fabric? Yes.
So,
yes, we are.
Yeah. No, I don't think you are.
We think it's awesome.
Thank you.
No, we don't.
So while using BPML and something like a drills engine, right, and just putting the database in transactions onto the blockchain.
So we don't use a blockchain anymore. We moved away from a blockchain about a year ago to a ledger. We changed
To a
the
ledger.
structure.
Yeah,
pretty much, yeah.
Because this workflow's been around a long while.
I mean, I started 20 years ago writing workflows, and now I'm back doing this is the future.
BPML. So it isn't BPML. It's your.
It's not. It's not a version, but yeah, it's BPM on top of.
And drills is the engine to do BPML.
Yeah, the issue with what we've found with all the BPM software we've looked at is because we have a transactional database, and I missed this bit. I don't know if it's there. I could probably show this if anyone wants to see this. The difference with the database is when you do a standard project on a database, right, you get all your devs in, you get your DevOps guys because it's the 21st century, you get your testers, your business analysts, whatever, and they all do the project and they all work on it, and like, everyone's heads down for 6 months. And then they're done, and they're like, brilliant, let's release the code, and then it goes up to security, and security says, no, that's our job. We'll decide the database rules, we'll secure the database. Because databases were built 50 years ago, and they're not really ever been, security's always been an afterthought of databases. But when you have a transactional data system, a transactional data model like a ledger, where I send you a transaction, you send you a transaction, and it just goes. Well, because we've got wallets and we've got public-private keys, we've got an inbuilt encryption. So if I want to send you a transaction, I don't want you to see it, I'll just use your wallet address and I'll encrypt it. And then if I want to send you a transaction, I'll just send you it and I'll use your wallet, because you're the only one with the private key. So that's why we had to build our own engine, because we can now, when we do our steps and we do our workflow and we build our steps and we've got all our fields and we do permission, The person creating the process at that point picks and chooses who gets to see that, and then when we publish that process to the ledger, that is unchangeable. If you haven't been given access to a bit of the data, you don't get it. And it's not like you can say, I'll go to the store and read it, because it's all encrypted. And it's all encrypted with, you know, the same encryption we use to protect Bitcoin. So if you want to start hacking it, crack on, we'll see you in 10,000 years. And then you'll have to pick the next one, and then we'll see you again in 10,000 years. I suppose Moore's Law, we could argue 1,000. But that's why we had to build our own, because all the workflow management systems really don't address this. You're not using a database under the scenes, so data permissioning isn't really built into it. It's like, it's there, but it's not.
The modern ones are. The modern ones use fully. Yeah, yeah.
We'll have to have a look at it. It's been about 2 years since we...
Funnily enough, I've done this with there's a German company I did it with.
Oh, cool. Well, let's catch up.
We should
Yeah, cool, because, I mean, yeah.
But I use BPML. And there's also a Microsoft version. Oh, we should talk.
Flow.
Flow.
Yeah, we looked at Flow, yeah.
Flow's not as advanced. This isn't as advanced as BPML and Jules, and
No.
Flow is not as advanced as
No. Yeah, but I used Flow in a previous life and it was cool.
Do you really manage to avoid the expense of APIs? I mean, I imagine these companies you're referring to are still using a lot of existing systems that they just want to integrate with what you're offering.
Yeah, so our basic answer is because Sika has everything's transferred over the Sika network, it's like you shouldn't really be writing your own. Like once you write your API into Sika, and Sika's got a standard API, REST API, whatever, once you're there, because we're passing data about very sort of key value pairs, whatever, and you're either getting it or you're not getting it, we're hoping that you really don't need to keep writing APIs between all the parties. All the parties just have to connect to Sika. You only have to write one API, or you have to deal with Sika API, and then after that you don't have to write all the APIs between them. Okay. You just need your one API to Sika, and then if you agree the process is sound.
As long as everyone comes on board the system.
Yeah, well, that is another problem with blockchain consortium or ledger consortiums. Is everyone must come to the party.
Yeah.
We wrote Sika so you could start on one, and then actually you can extend it as you go by just creating new versions of the process. You can add people, and if you want to be removed from the process, you can either delete your own keys, and then it's pretty much gone, or you can just get a new version of the process released without your active group in it, and then you're gone from the network. You will get no more data.
All the different parties you've mentioned on the diagram, do they all actually run full ledger nodes, or do you run them centrally and people access them?
So currently our deployment model is everyone runs a node, but because of the tier 3, the tier 4, the mum and pop stores, the little guys, they really can't afford to run a node. Like they don't have the IT infrastructure, they don't want it. So we are constantly trying to deal with, we're trying to work out how we can deal with that. We've got a few ideas, but we haven't put anything in practice yet. But it is on our roadmap that actually, what we'll try and offer blockchain or ledger nodes as a service that people could just sign up to. See, here's my little organisation, I need 4 wallets, give me access. But then you have identity issues attached to it. How do you know those guys are who they say they are? So we've also started dealing with trying to validate or dealing with parties who would verify them within the bigger network, because at the end of the day, when you're dealing with big guys like the Chevron and the insurance companies, they really need to be convinced that if they send a transaction to a little guy running in a workshop in Loch Gilphead, that is they get it and it's not somebody random else. So there's problems there, but we're addressing them.
You talked about the oil and gas example, the Deepwater Horizon, right? So if it was like company 1, 2 and 3 involved in the supply chain there, and maybe 2 was not part of it, is the concept that basically the lawsuit or whatever would come against 1 and 3, and they would give up their keys to show it, or does wallet services does wallet services have central control and access to it?
Well, currently what happened is, I can't speak exactly of Deepwater Horizon, I don't know, but I know how basically it's been, there's a mountain of paper somewhere, it's kept for 25 years until something goes wrong. And the only way to deal with that is you send the lawyers and they start people. What Sika's trying to do in this scenario is not so much replace that, not say, it's just to create a navigational system. So, but because of the fact that you can encrypt data and you can protect data, you can put trade secrets in it and know that you know, you can put it in saying, if I want to send you a trade secret because you're going to build a wellhead differently, I can send it to you and know that the other 5 parties don't know. So we're not so much trying to say, all right, this will solve all your problem, or, you know, company 2's, we're just trying to make the whole thing navigationable, so that if, for example, you discover that a forge in, I don't know, Falkirk was, you know, their systems, the IoT devices were saying they were heating to 800 degrees, and nothing about engineering. And actually they were 750, you could then use Sika to track every single thing they were involved in and say, guys, this isn't safe, you've got to pull this up, you've got to do this. Don't put it down to a depth of 10,000, it was only 750 degrees, it can be 5,000. So it's about being able to be traceable and trackable and have those options at a high, you know, more accessible to people rather than just doing, oh, if you want to find out, there's the paper, we'll see you in a month. So it's trying to cut down those costs. Did that answer your question okay?
I think I was trying to get an understanding of who's got the full visibility of the data, right? Is that customizable?
Well, so at the process level, some data is public and some is encrypted.
Yeah.
So nobody really has the full picture until the entire system is done, then you have access. And if you want the lawyers to get in, hopefully you know, we kind of envision that actually in scenarios like that, people would say, okay, we'll send you the data, we'll encrypt it to the lawyer's keys, and then they would then get what they need to determine.
Yep.
If you're using a distributed ledger but you're not using blockchain, how are you differentiating between the two?
I think blockchain is an example of distributed ledger. You've got graphs, you've got you've got loads of different types. Tags. You know, you've got all these different types. Blockchains is a single chain. You know, and transactions go on, it goes one way. But actually, that's really, you know, just one example. Distributed is just everyone has a copy and it's, you know, immutable really. How you store that is up to you. You know, there's other examples of it out there. Blockchain's just one. I mean, Pika, I think, or Sika.io, they've kind of made a big play on the DAG. There's a couple other guys that have done stuff with DAGs.
R3's a ledger as well.
Yeah.
It's not a
And
blockchain.
to be honest, like one of the things I think really has sort of troubled blockchains is blockchains were invented for cryptocurrency. They wanted everyone in the world to have a key. But if you have these shorter networks, these smaller networks of 10 or 15, and even 300, you could argue is a small node, then actually the rules change. And actually, so for example, our transactions are generally, you know, if you add data to our process, you know, we've got transactions of 50, 60, 70, 80 meg. Like, that's not uncommon for us to have these gigantic transactions. But that's only really sustainable because we have moved away from the native blockchain, which was all about size and allowing everyone in the network equal consensus. We don't have equal consensus. There's organisations, like if I do something as my organisation, I send that email off, I do that, it's done. Nobody gets to argue that I did that because, you know, my organisation, you know, I've done that, it's on the ledger. Nobody gets to say, oh, we all agree you didn't. No, I didn't. So we've got a kind of different authority, which we found only was supported when we moved away from the native blockchain.
Thanks very much. Thanks for all the speakers there, it's brilliant. Thanks for everybody who came along. You okay just to take your cans and stuff through there as well, is that alright? Okay. Thanks again everybody. Cheers.